welcome to this lecture on computer aided power system analysis. We have been discussing about power system state estimation. So, let us proceed with this. So, we are talking about the algorithm. So, let us just very quickly recapitulate the algorithm and then we will algorithm for very quickly, we have already seen it, but just to recapitulate algorithm for PSSE. So, we first have take initial guess, x naught and choose C k alpha. C k alpha is nothing but the threshold as obtained from the chi-square distribution for a given value of alpha. For a given alpha. We should also say that this alpha is also we choose, we also choose actual alpha, we actually choose alpha. So, we must also note that we choose alpha. So, then after that set k is equal to 0, this is the iteration count, this is the iteration count. Then what we do, we evaluate h I at x k, right, and from that and z I delta z I is equal to z I minus h I x k for all I is equal to 1 to m. M is the number of measurements. Then what we do, evaluate h x k. Now, what is h x k? That is the Jacobian matrix. This is the Jacobian matrix. So, this is the Jacobian matrix. So, and then after that we and we also set omega w is equal to R inverse matrix. W is equal to R inverse matrix is nothing but the weight matrix. So, this particular W matrix is this weight matrix. Calculate delta x vector, calculate delta x vector. Then we check calculate x I k plus 1 is equal to x chi k plus delta x I. This is for all I is equal to 1 to n. N is the number of states. So, n is the number of states. Then calculate max of absolute x I k plus 1 minus x I k for all I. Let us say this is epsilon, let us say this is E, we should write it more clearly, E is equal to this. Then what we do, check whether E is less than epsilon. If yes, states are estimated, x I x k plus 1 is the solution. If not, then what we do, we simply k is equal to k plus 1, and then go back to step 3. Go back to step 3. So this is the basic algorithm. Now after this also, so algorithm continued. So here also is the solution, and from then, and we should write here and go back to and go to step 9. So this is actually go to step 9. What do we do in step 9? We calculate in step 9, calculate zi hat for all I is equal to 1 to m. Then step 10, calculate ei hat is equal to zi minus zi hat. This is for all I is equal to 1 to m. Then we calculate f hat. Then what we do, if f hat is less than ck minus alpha, yes, no bad data, and therefore final solution is obtained. If no, if it is no, so then what happens? If no, go to step 13. What do you do in step 13? Calculate R dash matrix. We have already seen how to calculate R dash matrix. Then what we do, calculate yi is equal to ei hat by rii dash for all I is equal to 1 to m. Then we calculate position p as max of yi. This is for all I is equal to 1 to m, and find the index of p in the vector y. What is this vector y? This vector y is actually, this vector y is nothing but y1, y2 to ym transpose. So this is the vector y. Now after that, what we do, we find the location. Let this index be L. So therefore and hence Lth measurement is bad. is bad. So after that what we do, index into vector, let this index be L, and hence Lth measurement is bad. So then therefore what do we do? Remove the Lth measurement from this set of measurements, right? Go back to step 1. So this is the complete algorithm of the state estimation, which includes also the process of bad data detection. Now here, now we have to look into this, basically the structure of this Jacobian matrix. So now let us look at the structure of the Jacobian matrix. So now we are looking at the structure of the Jacobian matrix. Now here also we must do one thing. Now this hxk, we must note that hxk is nothing but is actually the Jacobian matrix you must note it, evaluated at x is equal to xk. So that is what is the Jacobian matrix. So now what is the structure of this Jacobian matrix? So now let my measurements are, so now let my measurements are let us say Zi is equal to Hi into x1, x2 up to xn for all I is equal to 1 to m. Right, we just for the sake that m is the number of measurement and n is number of state. Anyway, so now therefore what is this H matrix? So then therefore H matrix is nothing but, so then therefore this H matrix is nothing but del H1 del x1 del H1 del x2 dot del H1 del xn, and this will go up to del Hm del x1 del Hm del x2 dot del Hm del xn. So this is an m cross n matrix. This is an straightforward m cross n matrix. Now as we said that our measurements can be, let us say Pij. We have already defined what are this quantity Qij, Vi, Pi, Qi, mod Ij. Anything can be this measurement. So our overall set of measurements set is like this. We already know what are the expressions of Pi and Qi, that we already know, and similarly this Vi is also already know. So now let us look at that, I mean what are the expressions of Pij and Qij. So now let us look at some expressions. So now expressions for different quantity, expressions of the measured quantities, expressions of measured quantities. So we first note that Pi is simply I is equal to j is equal to 1 to capital N Vi Vj Yij cos theta I minus theta j minus alpha ij. Similarly Qi is j is equal to 1 to n Vi Vj Yij sin theta I minus theta j minus alpha ij. We should note here that n is the number of bus in the system, and we also note that n, that is the number of state, would be 2n minus 1. Vi is already known, so Vi is equal to Vi. Now let us look at Pij, Qij and Iij. To know that, let us consider a transmission line. This is bus I, this is bus j. In between there is a line, let us say this has got an admittance Yij, this is an complex quantity, and this is Y shunt, this is Y shunt, this is also Y shunt. So it is a standard pi model. These are all complex admittances, so we must write that these are not vectors. These are not vectors. Yij and Y shunt are complex admittances of the line. We must write admittances of the line. And what is Y shunt? And Y shunt is actually half line charging susceptance of the line. So if that is the case, so then this current Iij, so we are now trying to find out what is the current Iij. So this current is nothing but this current plus this current. So Iij is equal to I1 plus I2. So this is I1, I2. So then therefore Iij, is actually Vi minus Vj into Yij. Vi, Vj are the complex voltages. Vi, so it has got a voltage Vi, this has got a voltage Vj. We must also write that Vi, Vj complex voltages of bus I and j. And we also should write that Vi is equal to Vi angle theta I, and Vj is also Vj angle theta j. and let's say yij is yij angle alpha ij. Not, we should not write alpha because we are already utilizing alpha, so something else we should write beta ij. We should write beta ij, and let's say y shunt, and let's say y shunt is equal to y shunt angle, let's say gamma shunt. Actually gamma shunt would be equal to 90°, but just for the sake of it is actually should be equal to j gamma shunt. It is actually j y shunt. It is actually j y shunt, because I mean gamma shunt would be equal to 90°. So j y shunt. So then therefore plus vi into y shunt. So this is vi angle theta I minus vj angle theta j into yij angle beta ij plus vi angle theta I into j y shunt. So it would be vi angle theta I plus beta ij minus vj angle theta j plus beta ij whole of yij plus y shunt vi angle theta I plus 90°. So then therefore it would be vi cos theta I plus beta ij minus vj, it should be vj cos theta j plus beta ij whole of yij plus j. Now this is the complex operator, this j is complex operator. So that means j is equal to root over minus 1 into vi sin theta I plus beta ij minus vj sin theta I plus beta ij into yij minus ysh vi sin theta I plus j ysh vi cos theta I. Please note here also this j is also the complex operator, so this is also complex operator. So then therefore I can write down that iij is equal to, let's say something I real part plus j bij. Again I note that this j is actually the complex operator, and these j, these two j's are the bus index. So then from here I can write down that pij plus jqij that is if I am measuring Pij and Jqij at this point. So, I am actually measuring here Pij plus Jqij. This is at this point, at that is at this point I am measuring, that means at the outgoing point from bus I. So, then it would be Vi star, sorry, Vi into Ii star, sorry, Vi into Iij star. So, then therefore, this is Vi cos theta I plus j Vi sin theta I into Aij minus j Bij. So, then therefore, from here I can write down Pij is equal to Aij Vi cos theta I. So, Vi Aij cos theta I plus Bij sin theta I sin theta. Now, if I look at this expression, and similarly Qij would be Vi Qij Aij sin theta I and minus Bij cos theta I. So, now if I look at these two expressions, Aij is nothing but this plus this, and these are all only, this is j, I am sorry, this is j, this is also j, this is also j. So, now Aij is equal to this plus this, and Bij is equal to this plus this, and all these are only a function of Vi, Vj, theta I, theta j. Of course, here we are assuming that this quantities beta ij, and I mean we are assuming here that this all these line parameters are known. So, then therefore, and also I can write down that Iij mod is equal to root over Aij square plus Bij square, right. So, then therefore, I can write down that for all for known line parameters Pij is some function of Vi theta I Vj theta j. Similarly, Qij is some other function Qij Vi theta I Vj theta j, and mod Iij is also some other function, let us this call this function f. This is also would be functions of will be Vi Vj theta I theta j, right. So, all these quantities corresponding to line would be only the function of the terminal voltage magnitudes and angle of that corresponding line. So, with this we are now ready to look at the structure of the Jacobian matrix, which we will do in the next lecture. Thank you.